How you guys doing? This is Andrew at FloryPB. Today we're doing something a little different altogether. I said partially in the introduction to this channel, we want to show you a little more science. Nothing crazy. We're going to try to be very layman about how we explain this and what's going on, but this is going to be just hopefully an introduction and a way to help you identify what good regulators are versus bad regulators, especially with these older markers like the Angels that I deal with a lot, the autocockers, things like that. All the regs are conventional old style regs, which aren't built into the frame of the marker or anything like that. They're all set up where they unscrew, they're all 1/2 inch MPT threaded, and there's a ton of different regulators out there you can put on your markers. Now, which ones are good, which ones aren't as good, what to avoid, it sometimes comes down to personal preference, but there are physical differences between these regs, and I'm not going to go into like the actual design of regulators, so that might be a little too much, but we'll just do a little simple proof of concept just to show you what's going on in very, very basic terms and very, very basic layman kind of setup. But there's essentially two kinds of regulators in paintball. You have your inline regulators, which you see on most setups. It's a very common reg. Then you have what's called the cascade style regulator. The big identifier is with an inline reg, your macro fitting or your fitting for your air always comes in near the bottom, and it's going to go straight up in a line, get regulated through, and come out the top at the pressure you want. With a cascade reg, it comes in at the top, goes down, and comes back around. How that works is, if we break down the CP, only thing you see in the bottom of a CP regulator, or any real inline regulator like this, is you have the reg seat down there. And the piston's up in the top half. Come on. Of course it's not playing nice. And your piston will be up in the top half. So there's a little spring stack underneath the piston. And what this reg does is air comes up through the bottom, comes through the center of the piston, and starts pressing on it up here, up on the top of the piston, which then pushes down on the spring stack, and it lets the piston come down and close onto the reg seat to seal it off so no more air gets through the piston once it reaches the pressure that counterbalances or sets your spring stack to 0. The force the spring stack exerts versus the force down over the distance is traveled. Now what you do to change the velocity is you change the position of this reg seat. You bring it down or up to change the length and change how much spring force you're actually putting on it, because springs technically, they're a linear setup. So if you have a stack of springs or a big main spring, when you squeeze it, every inch you squeeze it, you get more force. Whatever the force is per inch of that spring, whatever the spring rate is on that, that's what you get. I'll be doing a bad job saying layman's terms here, but I hope you're staying with me. Now with the cascade system, like this Bob Long reg, this torpedo, in the top section where the air comes in, you have a valve. This is a little Schrader valve. Hope you can see that. A little Schrader valve in there, and you have a piston on the bottom of it like that. Now this piston, when the air comes in up top here, puts the air in there, it pushes down on this piston, which closes, lets the valve come up and closes it this way and shuts the air off to the pressure it needs. Then the air vents back up into the marker. Again, it's a different design. They both achieve the same thing, and arguing over which style is better really isn't what I'm trying to do here. I want to point out a couple things that we see. One of the main things I always say is mini regs are really bad regulators. They really aren't very good. Probably the worst reg, minus an ICD reg, if you count ICD guns as high-end guns. This is probably the marker, sorry. This is probably the worst high-end marker stock regulator ever in paintball, or in modern-ish paintball. And the reason that is, and I'm going to say the leading reason that is because of the piston. if you look at the piston, look at the CP reg, which isn't really even a good regulator. Look at the size of the piston head on this versus the Angel one. Now this size matters because, let's get the drawing out and let's see if we can draw some of this stuff. Or prove the math to you, basically. Now again, this isn't going to be how regulators are designed, because that would be a differential equation as far as that goes. But if we just want to consider what we can see, what happens is we have air pressure, right? Air pressure is in the tank. Your tank has a pressure in it. It's preset out. Probably if you have like a newer reg, the standard's like 650 psi. That's pounds per square inch. Now what you have on the top of this is you have an area that this covers. So the very basis of any kind of engineering or stress, what stress is pressure. Stress is a psi. And what we're saying is that stress equals to load or force exerted over an area. So you divide the amount of force by an area. Now if pressure is psi, you're going to times your pressure by your area times your area is going to equal the force that it exerts on this thing. Now why does that matter? That matters because if we look back on which one? Newton's second law, I'm pretty sure it's Newton's second law, if we go back all the way to physics, is force equals mass times acceleration. So this is acceleration. I'm going to say ACC. So for acceleration, that's not the same as area here, that's AR. So force equals mass times acceleration. And that's what we're trying to do. We're trying to max out our acceleration to make this reg close as fast as possible. What that's going to do is that's going to make your recharge between shots as short as it needs to be. The shorter your recharge, the more consistently your reg can shoot when you're shooting a stream of paint, which is a big deal. And the smaller your piston, the worse it is. The other thing's mass. But I'm telling you that area matters so much more. And I'll explain why. Let me just wipe this off real quick. When we look at this formula, mass and acceleration are linearly related. Means if you change one, it's a linear relationship to the other. The thing that's not linear, though, is area. Area is exponential. It exponentially grows when you make something a little bigger. So doing something quick and really down and dirty and easy is if you take the area of a square, right? Call this square 1 inch by 1 inch. That's going to be an area, if you fill that in, times 1 by 1, you get 1 inches squared. So if you make that 2 inches by 2 inches, 2 times 2 is 4 inches squared. So if you double the size of it, you quadrupled the actual amount of area that that has. And that same thing applies to a circle, obviously, as well. So if you're getting the area of a circle, you're talking about pi times the diameter of the circle squared over 4. So say you have something that's like half an inch. I'm not exactly sure if this is half an inch, but we're just going to go with that because I kind of know what that is off the top of my head. So if you have half an inch times 1/2 of an inch squared over 4, that gets you roughly, it's like 0.196 inches squared of area. But now if you say you have a circle that's an inch, an entire inch, not a half inch, pi times 1 squared over 4 is going to get you, I think it's 0.786 or something like that. I'm not calculating these, I'm just kind of trying to remember common sizes that I kind of know. So as you can see, your relationship from just doubling the size of it, you get exponentially greater area, and that's because it's a squared item. So the quickest way to make your reg more efficient or close faster is to up the area of your piston. And that's what Angel denies themselves with the mini regs. They're just kind of crappy because of that. Get all this blue off here. But that's one of the things that I really want to stress when you're actually trying to pick a regulator that you're going to use, is your piston size matters pretty much the most. But then there's more involved after that. Like if you want to really try to understand how a regulator works, it's going to be a differential equation, how it's set up. And there's a couple factors why it is. It's because the pressure coming from your tank isn't going to be constant. It's coming through a little hole, so it's going to start at whatever the pressure in the marker is, and then it's going to build back up the tank pressure over a certain amount of time. And that piston moves over a certain amount of time. You have a spring right there. You're going to have an oscillation in the spring, so there's a lot of... it's much more complicated than that. I'm not going to get into that, but realistically, if you want to just compare apples to apples and don't consider drag or anything like that, the most basic idea is that the area is going to dictate the force acting on the piston, and then you're going to have your mass, which is basically a constant, whatever the weight of your piston is, and your acceleration. So you're going to get your force divided by your mass, you're going to get your acceleration. And the more acceleration you have, the faster your reg can close. And that's what we're looking to do with any regulators, close as fast as possible. The other thing to consider is stability. How nice is the reg made? If the reg's made kind of crappy, like I think a big problem with CP regs, if I can actually get this out, I think a big problem with CP regs is the stability of the face seal. There's two seals, or there's three seals. You have one here, dynamic O-ring. You have an O-ring in the body here, that's on here, so this is stable as it slides up and down. Then you have this seal here, and this one, I don't have my crappy Allens, but I have my crappy Allens out. Just try to grab it. These aren't meant for grabbing, but oh. And this seal I don't really dig, because you have a ball that goes in this little ball carrier slot right here that puts sort of an axial load on the side of this thing, because it has to push it up and down because the ball goes up and down. So what happens is you only have one O-ring here holding this thing in place. So the ball's putting an axial load on this, and I feel it makes this thing want to pivot a little bit. It can't be much, but it's going to be a few thousandths of an inch maybe. But that pivot means that this thing's going to be turned a little bit, and when this thing comes down, it's not going to come down on a perfectly flat, straight seal. It comes down a little crooked to this. So I think that hurts the CP reg, and that might be one of the biggest reasons why these aren't as good as they probably can be, is because of that little setup they did there. But besides that, they should be a pretty good regulator. They use a lightweight piston. They can bore out a little more weight if they want to, just to make it give you a little bit of gain. But the piston's a good size. It has a good amount of area to it. So theoretically, it should be a very good regulator. And you know, they're decent, I feel. Not the worst things I've ever tested. The Angel regs are probably one of the worst things I've ever tested, unless you count ICD things as you know, quality paintball products. But that's a stretch at this point. That's my beginning spiel on regulators. That's hopefully lets you understand the idea behind, you know, what makes a regulator good and what makes a regulator worse than another reg. And it's not name brand or like that this reg was built just so much better quality. It comes down to the idea of the design. How decent did they assemble the thing? How smart did they make all their pieces when they did it? And that's going to really dictate what makes a better regulator than another. The other reg that I have a major problem with, these are three regs I have problems with that I'm showing you right now to start. This reg, obviously, too tiny. It also suffers a very similar fate to this with the piston itself, or the reg seat, excuse me. Sorry. The reg seat is acted on by a ball, which the ball itself, it's a little better because the screw, let's get the metric set out real quick. With the Angel reg, the screw imparts the moment or the axial force in the X direction on the ball bearing, which translates up. So it does a lot. It's not as bad as the CP reg at putting another force in your reg seat. But it's not ideal. I'd rather just be on the bottom and it go up and down on itself and have two O-rings that hold itself in place really nice and correctly. But it's not as bad as that, but the piston is so tiny and it's brass, so it's even heavier for most of the older Angel regs. The newer one switched over to aluminum, which helps it a little bit, but it's still missing the point that it's such a tiny piston diameter, and they killed themselves with that for trying to make a quality reg. The third reg, the other egregious reg, this is a reg that the problem is build quality. Straight up build quality is absolutely atrocious on these. Like 99.9% of any Bob Long product build quality is literally shit for high-end paintball. Hate to say it, I know there's a lot of Bob Long fans, Made in America and all that, but most of his stuff, or most of their stuff, is built like shit. And these, there is no difference. These are very bad. You hear that pop? Oh wow, this has the, so this is not even good. This one has a ShockTech piston in it. So this is a Bob Long reg in the nutshell. This is a ShockTech piston. The original Bob Long reg has one seal on the top, no seal on the bottom. So there's just one seal to keep this thing from pivoting. This at least has a second seal. It's not very far, so it doesn't help it too much from rocking, but it helps it a little more than the standard Bob Long does. Standard Bob Long piston does. Also, this one technically is probably a tiny bit lighter because there's a little bit less metal and a little bit more rubber on it. The other thing they do, which this one actually is kind of nice, this is a tuned up reg. These are saw cut normally, and they don't look this clean ever. So this one's been worked on before I got to it, which isn't what I intended to show you. I apologize. Maybe I worked on this one. This might be one I might have screwed up. I think it's one I messed with. Usually this isn't sanded, polished, nice and flat. This is kind of rigid because they just saw cut it and put it in. Which I'm upset I'm showing you this now, not the crappier one. But this is normally saw cut and not perfectly straight. It sits on this piston, which has one O-ring to keep it from wiggling, which isn't perfectly straight. Has this shitty carrier, which is just a stamped out piece of plate, which isn't perfectly straight. And this moves up and down by a center nut or a center bolt. Just pushes this up and down. Excuse me. Sorry, I'm a little sick, guys. So you have one point here and a wiggly wobbly thing here keeping it less consistent. The only good news is it doesn't have to be perfectly consistent because it's just this little head it's got to separate from. But the problem is this head isn't domed. They don't dome this because this is actually a Schrader valve. This is made by a real company, not a paintball company. This is made by a company that makes pneumatic parts, and it's a Schrader valve, and they don't dome the head. If they dome the head of that, this setup wouldn't have to be as rigid, but because this is slightly square, this thing being slightly off gives you slight variances that could have been eliminated if someone just had a little bit of foresight and made something correct. The other thing that bugs the shit out of me about these, there's no fucking vent hole. They didn't vent the screw, they didn't put a vent hole in the side, so you have an air pressure in here too. You have a spring constant rate, plus you have a variable air pressure rate. So the more you're pushing down on it, the more the air pressure is building up below it. It's just fucking stupid, you know? And all it needed was just a little bit more work. Maybe 5 more minutes of actual time to make this a much better product than it is. But we'll go through this another day ourselves, and I'll show you how to make one of these as good as you can make one of these. They can be really, really good regs. They're not from the start, though. They really are bad regs. That's just by poor craftsmanship. These are poor because there's a little bit of design flaw, I feel, in the bottom. these are poor from sizing. Not craftsmanship on either of these, but this one is craftsmanship. So all three of these regs have their own little demons with them, but all can be pretty good regulators to you. Now we're going to get in, I'm just going to show you how to do tests, but just going to go to black real quick. We're going to set up the test rig, and I'll show you guys how I test a regulator and how we can make a determination which ones are better than other ones. Now I'm not going to make this definitive buy this reg over this reg test, because I'm only going to test one of each kind, but I'm going to show you, where you should go and why the theory should hold true on what's a better reg than another reg, and we can just do a little learning and a little experimenting from here on. So be right back. I'm just going to set up the rig and get started and show you that. Alright guys, so I just set up the testing rig for you to see. I use an Angel A4 as my testing rig. I use this for, basically it's a perfect marker for this. The Angel A4s, they had this weird little gauge that they put right behind here, which is the perfect port for me to come up with this little T. I use this as a pressure gauge just to see what my pressure is at, to see what I'm going to convert my pressure to, because this gives me a voltage reading. So I'm going to see what I'm relating myself to. And then I use this little pressure transducer. It's a 300 psi pressure transducer that I got off eBay. It's a cheapie. That's connected to my Arduino board. And I just use this very simple code. It's very primitive, but it's enough to get me a decent enough reading. It's not a reading I take to the bank. It's nothing like that. But it's decent for comparing regs to regs. And if you make any changes, seeing if it actually helps or hurts the reg that you made changes on. I would never take these numbers as official drop-dead numbers solely because I'm not testing enough regs of a certain brand to make a certain assumption. I'm relying on this gauge being accurate to be my starting point, which I have no calibration data on it. This is a cheap $20 eBay sensor. Again, no calibration data on it. I wouldn't feel comfortable making this an official test, but for what we do with this, it's good to see, and it'll be able to compare one reg to another reg in the inventory of regs that I have. So it's very simple. And the other beautiful part about the Angel, minus that port, the LPR is very consistent and very good on Angels, so I don't get weird LPR fluctuations hurting me. That'd be very minor if that hurt me at all. And the other thing is, this is set in auto mode at 10 balls a second, but you press the middle button on the Angel pad in auto mode, you go back to single shot semi. Then you press the middle button, and you get 10 balls a second auto. I test them at 10 balls a second because that's what you shoot now in a tournament scene, so I figure it's a decent enough test. If the regs can hold their weight and be pretty consistent, which the pressure they get back to in a 10 balls per second test, it's an okay reg for you to use. So without further ado, we just plug in our Arduino board. This is going to be hard for me to see. I'm going to upload the code. I do this very primitively. We're going to monitor the serial port. Do 5 slow shots, put it in auto. Do a little burst. Pull that out. Now these numbers that we got here, this is a milliseconds in the left column, and that's voltage in some weird ass number in the right column. This is incredibly difficult for me to see. I'm sorry about that. So let me open my notepad real quick. Killing me. My keyboard on this old computer kind of sucks. There we go. CP test. This won't be an official file of any kind. open up my Excel file, go over to data, from text, CP test, delineate it rather, is delineate with a comma. My data is in. My voltage conversion, 178, I like that. So let's pop over to the chart, and we see what we did. So this is the reg as it's being tracked on my voltage or on my reg tester. Let's try to see everything here. So the first shot is about 1,000. Yeah, it's pretty good. I mean, so you see the consistency and the lack of consistency in this reg, and you see where it's rolling around. So here's our input pressures around here. The first shot dropped us down pretty low, came back up to a less pressure, but it built for the second shot. These were the 5 slow ones. That didn't draw down as much. I'm not sure if it just missed the point there, but you see how the drawdown's going, how much pressure it's losing on each shot. That could be consistency of the marker. But this is where it's returning to, and when you're doing the slow shots, here's your consistency differences. Every height difference, that's, you know, a different chronograph reading basically, minus your ball to barrel match. This is the other thing that's going to give you differences in your chrono readings. Hope you can see that well, right? Let's see, maybe do that, right? I don't know. I hope you guys can see this correctly, because it's hard to do right here. But the real attention that I bring is, look at this little creep it has. So it started here. After I did the 5 shots, it was creeping back up a little bit higher. So really, really long, drawn out creep to this point here, which isn't crazy. It's not like I'm dealing with a lot, but I'm dealing with a couple PSI. And then here's the rapid fire, 10 balls a second. You see where it chronos. This is where you're chronoing when you're taking these slow shots. You're chronoing it up here. Then when it's shooting 10 balls a second, you're losing it a little bit. Your velocity be lower in your first couple shots here. It gets a little better for some reason, but it's creeping up the whole time. This is kind of creeping up. So it's a little weird. And I think part of that is just the inconsistency because of the axial force that the ball's putting on it. It's making it crooked and it's fighting it straight. It's fighting itself closed, and you're getting some creep issues with it. And it's interesting to see. I mean, the marker's going to be pretty consistent. The LPR is pretty good. The solenoid's just controlled by dwell, which is what it is. It's just an electronic signal set. So that should be pretty consistent. My tank has enough air in it. This is just the reg itself. And you're going to see these weird little things in the regs. Again, I'm not going to say this reg's better than another reg, worse than another reg right now. But I just want to show you the baseline of how this is going to work. And you're going to see me do a lot more of these reg tests in the future. Especially with mini regs, especially with any reg that I'm really working with. And I'll show you little tricks to try to improve the reg, and you know, we can see together what makes a good performance reg. Other things, I want to test LPRs. I want to see how much of a difference expand or volumizers make when you put bigger volumizers on and you have less actual drawdown of the pressure in your chamber. Hopefully, how much does that help your reg? Input pressure is going to be, that's a different thing. Of course, if you have an 800 psi input pressure versus a 400 psi input pressure, you're going to be able to put more force on, so it's going to work a little faster. But some regs can't take that much pressure, so that's a problem for them. But we're going to go through all these little things, all these little tips. I would always definitely say put the max amount of tank pressure into whatever your reg can handle. If it's like an old CP reg, I'd give it the 800 psi. If it's, you know, an Angel Mini reg from this vintage, you got to give it a little less pressure, like 600, 500 psi. But always give it the most pressure you can, because that helps you generate more force. More pressure, more force, right? More force, faster acceleration. And some of these regs, we can, you know, machine some meat off of the pistons. We can change out some of the O-rings to see how that reacts differently and better. And, you know, we're just going to play around with these as we go, as time goes on. I just want to give you guys a quick introduction to this. And yeah, we're good for now. Questions, comments, likes, please subscribe. And yeah, that's it for now, and you'll see more of this in the future.